Hello students, welcome back to Future Foundation. Students, in this video I will discuss question of area under the curves which was asked in JEE Main 2025 held on 29th Jan shift 1. So let's start. Students, question is, let the area of the region x comma y such that 2y less than or equal to x square plus 3, y plus mod x less than or equal to 3, y greater than or equal to a mod x minus 1 be a, then 6a is equal to. So students, in area under the curves, what we do first, we draw first given curves if possible, right? So as here we are having inequalities, so corresponding to these inequalities we will write equations and then we will draw their curves. So let's say C1 is 2y is equal to x square plus 3. C2 is y plus mod x is equal to 3. And C3 is y is equal to mod of x minus 1. I am drawing these curves. So student, these are the three given curves. Now let us write where they are intersecting x-axis. This yellow curve, which is C3, is meeting x-axis at x is equal to 1. This white curve, which is C2, is meeting x-axis at x is equal to plus minus 3, right? And curve C1 is not meeting x-axis. It is intersecting y-axis at 0 comma 3 by 2, right? Also curve 2, also curve 3 is meeting y-axis at 1 or 0 comma 1. Now we need to find their point of intersection so that we can find area under these curves. So if I solve C1 and C2, now solving C1 and C2, we get square plus 3 by 2 is equal to 3 minus mod x. And if we are interested in left part of these curves, so we will put x is less than 0. So from here we will get x square plus 3 is equal to 6 minus 6 plus 2x, where x is less than 0. So from here x square minus 2x minus 3 is equal to 0. So x is equal to x minus 3 into x plus 1 is equal to 0. So x is equal to minus 1 or 3. But we can see we are finding x for x less than 0. So x is equal to minus 3, minus 1, right? So one student might think that, sir, how did you draw these curves through the same intersection for all three? So in this thing you can understand by finding point of intersection, as I have already found point of intersection. And now again on solving C2 and C3, we get 3 minus mod x is equal to 1 minus x, and x is less than 0, so this will be 3 plus x. So 2x minus 2 implies x is equal to minus 1. So 2 and 3 are also intersecting at x is equal to minus 1. So this is the point x is equal to minus 1, right? If I see the inequalities, then this is the region which is bounded by all these three curves, right? And we can see clearly it is region from x is equal to minus 1 to x is equal to the point to this point, which we can get by solving yellow curve and white curve, that is curve 2 and curve 3 again. So again solving C2 and C3 for x greater than 0, we get 3 minus x is equal to x minus 1. So this will be 2x is equal to 2 implies x is equal to 1, right? So it is x is equal to 2x is equal to 4 implies x is equal to 2. So this is x is equal to 2, right? So we can see from x is equal to minus 1 to x is equal to 1, this is area under the parabola and line y is equal to 1 minus x. And from x is equal to 1 to x is equal to 2, it is area under the line y is equal to x minus 1 and y is equal to 3 minus x. Okay, so I am also writing equation for these. So this is y is equal to 3 minus x, this is y is equal to 3 plus x, this portion is y is equal to x minus 1 and this is y is equal to 1 minus x, and this parabola is 2y is equal to x square plus 3, right? Now area is equal to, or required area. So now required area is equal to integral minus 1 to 1 y of parabola or y of curve 1 minus y of 3 curve 3 dx plus integral 1 to 2 y of curve 2 minus y of curve 3 dx, right? So it will be integral minus 1 to 1 y of parabola, that is x square plus 3 by 2 minus y of curve 3 1 minus x minus of 1 minus x whole dx plus integral 1 to 2 y of curve 2, which is 3 minus x minus y of curve 3, which is x minus 1 dx whole dx in fact. Also students, I am mentioning that point of intersection or x coordinate for point of intersection for curve 1 and curve 2 is also 1, right? So now we can solve. So it will be half times integral minus 1 to 1 x square plus 3 minus 2 plus 2x dx plus integral 1 to 2 4 minus 2x dx, right? So it will be half times integral minus 1 to 1 x square plus 2x plus 1 whole dx plus integral 1 to 2 4 minus 2x dx. Now if I integrate this whole, then it would be x plus 1 whole cube by 3 within the limit 1 to minus 1 to 1 plus 4x minus 2x square by 2 within the limit 1 to 2. So it would be 1 by 2 times 1 plus 1 whole cube by 3 minus of 0 plus 4 into 2 minus 2 into 2 square by 2 minus 4 minus 1. So it would be 1 by 2 times 8 by 3 plus 8 minus 4 minus 3. Now it would be 4 by 3 plus 1, and which is 7 by 3. So area is 7 by 3. So therefore 6a is 7 by 3 into 6, which is 14 square units, and our A is 7 by 3 square units. So 14 must be one of the 4 options. Yeah, so students, option A is correct. Let's meet in next video. Till then, bye bye, take care.